I'm Thomas Hall, Executive Director of CleanStart. Many of you know me and are kind of familiar with our programs, but today we've got a great discussion and let's get right into it. But first, I want to thank our sponsors who help us and others build clean tech companies in the greater Central Valley region. SMUD, our local utility, which has one of the most aggressive net zero emissions plan, not net zero, absolute zero emissions plan by 2030. Bloom Workspaces, which is a place that hosts us when we need all of our team mating. Fresno State, the Wet Center there, which is innovation on water, energy, and technology, focusing on irrigation and agriculture. River City Bank, which if you're looking at doing a project, they have done lots of renewable energy projects and are very familiar with the financing around them, and our partners up in Northern California at CleanStart. And with that, I would like to welcome our guest today, Evan, CEO and co-founder of Open Road. Open Road is a charging company, and they have a new kind of spin on it of how they're going to try to get charging or make charging more accessible to more people, which is really important if you know how hard it is to find charging. If you've ever lived in an apartment, say, or lived in a place that might not have a garage that you can charge in. So I'm going to welcome here. I'm going to stop sharing and let him take over to introduce his company.
All right. Yeah. Thanks, Thomas. I'm going to try and share here.
Give me 1 second.
Oh, yeah. Too quick.
There you go.
Okay. Now it should go. Okay. You can see my screen.
See, it looks good.
Okay. Let's go. So, yeah. So I'm a CEO of Open Road, and we're sort of a new early stage startup here in California and Michigan, but I'm in California right now, Bay Area. And we're basically a prototype stage in the product I'm going to talk about here. But I want to talk about the philosophy that kind of got us to this product and why it addresses some particular concerns in charging, both sort of for California and sort of for America as a whole. So roughly speaking, I want to talk about how we're doing fast EV charging, both at the grid edge and just off the grid entirely. So I'm kind of I say I'm an EV enthusiast. This is pretty new. This is like over the past year. I was sort of not an EV enthusiast until recently, but I've become both an enthusiast and an EV optimist in the sense that I think this is an inevitable technological transition, no matter what the short-term trends are on EV purchasing this year or any kind of political winds or particular opinions about climate or not. I think this is a large-scale industrial technological trend anyway that is sort of a thing we should all kind of think about and deal with and enable, but it's just going to kind of happen at some speed. Whether or not it meets optimistic targets, it's going to meet targets. Overall, I've been doing startups for about 20 plus years, since around 2000, mostly in software in the early stages. But in the last 5 years, I've worked at a couple of different light vehicle companies, light EVs, Razor and Acton, and a couple of big companies, Google. But in the last sort of period, I was present all through the kind of micromobility wave, the wave of light electric vehicles suddenly becoming popular, and the whole phase around like Lime and Bird and so on. And that was another early wave of this technology change I'm talking about, which is that batteries got just good enough to make small vehicles with decent range practical suddenly around 2018. So there's kind of this slow lurking trend in electrification that is a little bit hard to see, but it keeps on marching relentlessly every year. So the first big boom was like scooters everywhere. And then there's economic problems with operating scooters, but it's not a technological problem. And EVs are kind of on the same trend line. They're just slowly getting better and better in a way that's hard to see, but they will disrupt classical cars anyway at some velocity. It's just going to happen, I think. So what we're kind of addressing as we see this trend coming is there's kind of two sets of pain points around EVs. There's the ones around EV ownership and driving right now. Range anxiety or, not enough charging, obviously, or access to charging in decent places at decent speeds. But there's also the demands these things place on the grid. And at the same time, the demands on the grid because we're simultaneously moving to renewables as a power mix. So you get a lot of solar in California, but it's all at once. And EVs tend to charge at certain times of day, all at once. My neighborhood in particular is becoming overloaded because it's full of Teslas. I'm in Cupertino. The local grid is really, really strained here, to the point that PG&E is trying to take houses off the grid with batteries and solar just to alleviate this in the short term. And of course, AI data centers have now come along, and now there's a lot more demand for power suddenly from a whole new thing we didn't see coming. So roughly speaking, the charger market kind of looks like this right now. There's a lot of level 2 stuff at the low end that we're all familiar with, the wall chargers. There's various home battery products that don't charge cars really. And then over at the upper right hand, there's a lot of high-speed chargers that everyone focuses on building out, this nationwide charger network. But it's very expensive and complicated stuff. It's very kind of, high capacity, 20 big chargers in a site, but there's sort of nothing in between, both in the product space and in just the public charging space. There's a big gap in the middle between low-end home, high-end industrial. And like I said, the grid also has this challenge where, and this is kind of an interesting graph, this is from about a year ago, but you can see kind of the power stack of where we get electricity in California. I mean, natural gas is doing a lot of work here to fill in this problem. We're trying to build out batteries and large public installations. That's the blue stuff on this graph. It's expensive though, compared to storing natural gas on site. Putting power in batteries is just costly. So we're trying. So during the day, we store some of the excess solar. During the night, we use it in the evening. But this is one of the bottlenecks of really pushing more renewables in California is we just have to we have to shift things from the afternoon to the evening in a more effective way. So here's what we're building. We're building a hardware software platform that involves using batteries to do high-speed charging, but also using batteries to store power and time shift power. And these problems are kind of interrelated. They're happening at the same time. We're trying to solve both of them in a co-located way. Here's our upcoming design. So this is a modularized design for a couple of reasons. It's easier to install because you break down the weight, easy to transport, but also for a bunch of technical reasons I won't go into. A lot of stuff gets cheaper, safer, easier, and better when you start breaking up the electricity and you don't put too much current or too much voltage in any one place until you get to the car. So for all these reasons, for a whole bunch of sort of engineering stuff we've been doing in the background for a while now, we've come up with this design where we put ultimately a few kilowatt hours in a box that weighs about 50 pounds, and you can stack them up and you can aggregate the power output. And then essentially it's power electronics that then delivers that all at once to the car. So again, why are we putting batteries and chargers together? One thing is we get a couple different interesting form factors here. We can do portable charging, so you can basically make a portable power bank that still charges quickly enough that it's really convenient when you have to pull over and get some power, or if you want to have a bit of a safety measure on your fleet vehicles or your rental cars, or whatever. So we can take some of this modular design and put it in a small box, or we can stack up more modules in a big weatherproof box and get the thing on the right, which is typical roadside form factor. So again, our design currently is 6 of these gets you 150 kilowatts, which is, undisputably high-speed charging. But what the batteries do for us is sort of what we think of as analogous to issues in like historical issues on the internet in data bandwidth. I mean, you've got the early days of the internet, there's a lot of video and content people want to put online, and you just couldn't get it into the houses fast enough. So over time, we evolved all kinds of solutions around buffering and caching, and then you could watch videos online and so on. And this is sort of analogous to that. We have a grid that no matter how fast the cars are able to charge, it's hard to get the power in real time to that car over those wires, both the kind of macro grid around the site and even on site, just like how fast can you get power across a parking lot? I mean, what do you have to trench to get there? So the battery lets you take slow power from conventional circuits, even just regular wall outlets if you want to, store it up for a couple hours and then blow it very quickly into the car. So you get fast charging in a slow circuit. And that's the big advantage here in terms of footprint, in terms of ease of access, in terms of equity of installation, in terms of site selection. You don't really have to upgrade the grid first to get fast charging to this extent. So it's buffering, fast output from slow input. It's caching. You can store energy up when either the car's not there yet or the energy is cheaper. And then, yeah, finally, time shifting. You can move power from the yellow part of the duck curve to the evening part where there's no solar. And like I said, this would be an example mock-up for highway use. You wouldn't have the modules exposed. You put everything in a nice kind of weatherproof case with a payment interface and so on in the usual manner you expect. And the reason why I keep talking about 150 kilowatts is that this is the federal designation for the low end of fast charging for the nation's charging network we're still trying to build out. And we're still in the early stages. And this is the program that has several $billion available. And as people say, it's only built like 7 chargers. It's actually a bigger number than that. It's like 35 or something. But we're obviously not very far along towards the 5,000 charger goal on this highway network we're trying to get to. And to be fair, it's hard. I mean, once you kind of get out of the big cities, it's hard to get real-time, high-speed power bandwidth into the dotted lines on this map. So we think some kind of battery-based caching buffering solution is critical to just making this work. And so there's a lot of green field here if you can elegantly put these things into a product. And we're, again, going for a pretty low footprint. I mean, you should be able to drop these things into gas stations or small retail locations, just wherever you've got consumer grade power, you could put this thing in place. Now, if you're going to put a bunch of batteries on the internet, you should also do virtual power plant stuff, which is the other half of the demand thing here, the other half of the problem space. You can use these batteries to, again, take up power when it's cheap or when it's plentiful or when solar is being just discarded or curtailed. And you can also use them to give power back to the grid. And you can aggregate these things into the equivalent of the thing on the left, the virtual power plant stuff people here are probably familiar with. So we joined the Open ADR Alliance. We'll comply with those new APIs and so on. So we're going to interconnect to both standard charger management endpoints, OCPP stuff, and standard distributed energy endpoints, Open ADR stuff. So we're doing both things in one place. And to the extent that you want both of those, and it turns out a lot of customers do, we're kind of the chocolate and peanut butter solution to kind of satisfy two things at once. So our target markets kind of look like this. I mean, we'll start with the portable form factor to EV fleet operators because, I mean, honestly, it's the easiest sale. We're getting LOIs now for this. I mean, that's just, you make that, people will buy that. And as light electric vehicle company people, we're kind of experienced selling to fleet operators anyway. But after that, we want to go into the commercial charging market and start getting these 150-watt things placed out there. Just because in the short term of the next couple of years, there's a lot of subsidy available to get this thing kind of kickstarted. It's not forever. So we think cost is actually going to matter at some point. So we want to build a kind of a cheap, accessible product so that it can survive without subsidies. But obviously, in the short term, there's a lot of subsidy. And then finally, there's kind of this interesting market where power utilities, and PG&E is doing this here, is starting to co-locate home batteries behind the meter with solar. And this would work well for that as well. Because now you have a package where you can get home power resiliency and all the kind of demand response and grid resiliency stuff PG&E is trying to get by installing power walls, and you can charge your car fast. So this works because to make all those things work at once, you have to put the battery physically near the car charging because that final bit of power delivery is very high bandwidth power. So you can't put it 200 feet away. So again, this only works if you build a battery-based charger that's very, very low footprint and can kind of go anywhere. And then you get all the advantages in one place and you can put the batteries near the car. So this is good for locations anywhere at the grid edge, either in underserved urban locations, really dense locations, multi-unit buildings that just can't bring a ton of power. But also the whole rural landscape of places where the grid's just not going to be high bandwidth anytime soon because we can't build a whole new grid very quickly. So we're an American product. Our engineering is American. Software stuff's predominantly here in California. Hardware stuff's predominantly in Michigan. Working with the university out there. There's a lot of kind of good automotive adjacent engineering to be had, obviously in Michigan. So this two-state solution kind of makes a lot of sense for us. And we are trying to avoid any kind of critical China dependency in our parts. I mean, obviously everything has something from China, but it's important for a lot of these markets, both for federal national interest subsidy reasons or perhaps national security reasons, to avoid having critical communications parts from China and so on. So this should be as made in America as it needs to be for any particular application, to the greatest extent possible. And here's where we're at. So the thing on the left is a prototype we're really close to finishing right now. This is the suitcase charger. It's a 50 kilowatt charger you can move around. And it's the biggest suitcase and it's heavy, but it's very, very portable compared to anything else that's ever been done. And this will put out about 50 kilowatts of power. And then once we complete that, we're moving on to the modular design where we can stack up to 150 kilowatts. And so these are kind of the early stages of both of these product lines I'm talking about. And so we're hoping to be able to start interacting meaningfully with potential customers, even for the thing on the right, probably sometime later this year. And here's our lab in Michigan. Like I said, we're at TRL4, which basically means we have stuff working in lab conditions. We're hoping within a month or two to have stuff working in field conditions, like, tote something out in the parking lot, start charging cars. And that's essentially where we're at right now in this company. And that's why we kind of arrived at the product we have. So that's kind of a high speed trip through the whole vision. But happy to answer a lot of questions now.
Sounds good. If you want to stop sharing there.
Yeah, I can stop sharing here.
Go ahead. And so I do see a question in the chat, but first I want to kind of ask you about, I mean, I think I love how you came out there with like, hey, here's the problem that we're trying to solve, and that it's really expensive to install these at their final location. And you kind of you showed a novel kind of solution in there where it was the battery on wheels, where you wouldn't have to maybe do as much engineering, retrofitting, digging trenches to be able to pull power across if you can just drive the battery across the parking lot. And then I also noticed that you were talking about your kind of initial to go to market ones where you had fleets, which it seemed like that might be part of the solution for the fleets, is a battery that can move around. But also you mentioned, the kind of brick and mortar locations there too, which there is, a lot of competition to go after that federal money to be able to go and build these across the United States. How does putting them on wheels enable you to maybe go, I guess, connect with your initial customers and potentially maybe go after, are you able to go after the federal money if it's on something that's portable, or does it have to be built in?
So yeah, and again, I know I showed a lot of mock-ups quickly for the federal money or any kind of outdoor charger. Yeah, it's going to be a fixed install probably. So you wouldn't put the wheels on it. You'd put it in a big weatherproof case. It's got to comply with various regulations and so on. You have to have a payment interface. It has to take credit cards.
Mhm.
So it's a different shell and some and different hardware wrapping and some stuff in the middle. But the point is that it's still going to be comparatively very, very easy to install because you can. The ideal is no trenching and hopefully a couple of people can kind of stand these things up pretty quickly as opposed to having to do a big industrial install. Less footprint, less demands on the site, and in theory, just plug it into the wall.
Yeah.
Yeah. Now, I mean, you may have to hardwire it for some electrical reason, but like in principle, any regular circuit will do. No site upgrades should be needed. So the real advantage there isn't so much the wheels and the moving around; it's the ease of being able to kind of drop it anywhere.
So if
You know,
you're a fleet operator and you're going to have one of the ones that moves around, is it, I'm assuming you're charging it probably at, at 240, not at 110 at a faster charger. And then you,
yeah. I mean, you could do 110; it would charge
yeah.
overnight. But yeah,
Well,
the
I mean, how big
ideally
are,
240. Yeah.
how big are the batteries that you're putting in there? How big could they get to? What's the range?
So the current sort of model, the stack of six is 20 kilowatt hours, which is kind of like a third of the range of your car that you're going to typically use between 20 and 80 and so on. So
Mhm.
it's not charging the whole car. I mean, we can extend this product as far as we want to. I mean, we could add more and more batteries, we could go faster, we could have more capacity, but we think there's currently a sweet spot at the low end that's just kind of going unserved. And so we're starting with that. So yeah, the answer is 20
Mhm.
kilowatt hours. Your car probably comes with about 80, but you don't really stay between 20 and 80% in the battery. So you really have like 60 and so on. So it's kind of like a third of a tank, I guess, to put it really crudely.
Okay. And do you have IP status or protection on it?
Yeah, we got a big patent across the whole thing. We're filing a bunch of sub patents sort of under that umbrella. And it's just sort of like this idea starts to sound kind of obvious when you kind of put it the way I just did, but there's a lot of innovation to kind of make it work. There's a lot of grindy stuff to kind of get all these details to be safe and effective and cheap and light and so on. So yeah, I think there's a decent amount of IP here. I mean, obviously, with hardware, you always worry about once you've done it, people can sort of make it. But I mean, we think it's not just IP protection on the hardware. There's also a lot of software to lead with all this too. And software is easier to defend than hardware. So the overall platform, we think, has kind of platform advantages, over and above the hardware IP as well.
How would you compare yourself to like Charge?
Yeah, I saw the goodbye in the comments. So we're basically cheaper, lighter, and faster. I mean, it's just more, I think, more iteration. So Spark Charge came out, I think, 5, 6 years ago, and they've got this kind of, they've got a 20 kilowatt roadside charger, but it's a lot heavier and it costs a lot more. But also, I think they're focused on the franchise operation of operators charging cars in the field. So I think they basically got a design out there. I'm sure it's fine, but they're not iterating on hardware so much as iterating on the business model of their like the operational side of having branded trucks go out and charge stuff in the field. So it's a different kind of business model. We're focusing specifically on kind of pushing ahead on the hardware itself as opposed to the operational stuff.
Mhm. You mentioned fleets, but what about, multi-unit dwellings and apartments? How would you imagine it kind of impacting them?
So again, we're trying to avoid trenching, we're trying to avoid site upgrades, and the one place you have to go at that point is maybe during the day during peak hours. There's just not enough power to charge a lot of cars, but at night people are sleeping. So the whole philosophy of this product is take unused bandwidth and power at different times of the day or whatever, and just shift it. So this drops into a multi-unit building because it's pretty easy to install. You can just plug it in. It fits physically in the existing underground parking garages pretty easily because it's not a big footprint. It's fairly cheap compared to everything else, TBD, but it's an order of magnitude cheaper than a lot of stuff just because we're really going for cost advantages here. So it's a pretty low threshold to install. And again, I mean, today you can probably get a lot of subsidy for that, but even tomorrow when you can't, we think this will be an appealing product for those reasons for multi-unit buildings.
Okay. Now, how much do these weigh? I kind of imagine, you put them on wheels and there might be, I realize that the mock-up there probably wasn't the finished design on the wheels for it, but is it powered like can drive around? I know there was a company, FreeWire,
Mhm.
that they had these giant, battery packs that were remote control that you had that had powered wheels on them. Are you imagining people push this around or are they powered?
It should be like when I say portable, I mean that in a few different ways, but rollable easily is one sense of portable. And yeah, it shouldn't weigh that much. So the target goal and the reason why we got that modular structure is trying to keep each piece around 50 pounds or less, just because it's kind of a general OSHA guideline that's,
Hmm.
about 50-pound objects. And so if you stack up six and put some electronics on top, yeah, I mean, off the cuff, it's like 340 pounds. So it's not awful. And it's relatively easy to put up and take down again. And we want to have the portable one to be liftable by one person. I mean, batteries are kind of heavy. They get a
Hmm.
bit lighter every year. So batteries are our biggest kind of governing weight factor here. But
They
yeah,
don't get lighter, they just get more energy dense. So
well, no, but that's the same thing. You can use less of
yeah.
them. Yeah. So
But everyone will go push it to the most capacity that they can, and that OSHA thing is probably what's going to limit them more than anything else. Now, we got an interesting question in the chat about the kind of economics of it, and this is something that I've actually heard from fleet operators. Basically, they like to say, like, I bought a gallon of gas, I put a gallon of gas in the car. They might have a small amount if they have enough gas sitting around for boil off. But when moving power around, there is a definite small percentage of loss going from the wall to the battery, then out of the battery into the car. How do you kind of accommodate for that when you're at like a multi-unit dwelling or you're working with a fleet so that they can understand their cost?
okay. Well, in terms of that level of loss, I mean, one key here is moving power over fairly short distances. So again, putting the battery right next to the car is better than putting the battery across the parking lot.
Yeah.
So a lot of stuff here is premised on having short distances of power transmission, but also short time duration. So we're talking about just several minutes of fast charging here. And so because of that, you don't have as many thermal considerations because it takes a certain amount of time for heat to build up in copper. So, I mean, there's always loss, there's always entropy, but those particular losses aren't one of our biggest issues, we think, just because of the short time, the short distance involved in the product.
We got actually a question from online on our stream, from someone that's Smud. Are the target customers commercial or all car users? Do you see a bridge solution for commercial heavy duty truck charging where there's not enough juice to the building? Which I think you might have answered some of it, but you would care to expand?
Yeah, generally our targets are commercial. Now, I mean, we love to build a product that could also be made a retail product. Like I put one in my house, of course, and it's great. But for just a few different business reasons, it's just we want to target B2B and commercial, either fleet operators or buildings or that kind of stuff initially, just because selling direct to consumer is a whole other set of challenges involving marketing and different strategies and so on. And you just don't want to do everything at once. And historically, we've been in B2B companies, and so that's our lane. I think it's a good one to start. And also, it's just there's some big markets there that are kind of right now easily accessible. But ultimately, yeah, it could be all of the above. But commercial is the answer in the roadmap right now.
That's one of the best parts about, Billy being an entrepreneur and a startup. You get to sample your own goods. Um,
Yeah, for sure. Yeah, no, I mean, this obviously comes out of personal experience, the whole product, but
yeah.
there's a lot of kind of like subtle use cases that people don't know about. Like for example, at Detroit Airport, I mean, Hertz has big banners saying rent an EV, and I went there a few months ago and said, why don't I see an EV? And they're like, oh, okay, if you wanted one, we could have got one ready. We don't really rent them. I'm like, why don't you really rent them? And they said they couldn't turn them around fast enough because there's no charging on site that was quick, and the airport can't bring in more power. It's an airport. It's not near Detroit, really, or it's not near the high part of the grid. It was too much work to have to drive them out to a fast charger and bring them back. They just couldn't do the turn time. So
Mhm.
again, I mean, if you could bank power and shift it a little bit, you can imagine like solving that problem with just not that many batteries would make that go a lot smoother. So there's always edge cases that almost work. We think there's things like that out there as opportunities.
That's actually a problem also here at the Sacramento airport. We have the airport slightly outside of town, needs more power, and airports, they've got a lot of special rules and controls around them. So Gary's asking about, I actually like this one. So you have a battery on wheels.
Mm.
I'm in a hurry. I just need to top off my EV. I push, it, or I drive the thing, 20 yards to my vehicle, top off my vehicle, leave it there and drive away. Equating it to Gary equates it to someone leaving like a shopping cart in a parking lot. Now these are significantly heavier, more expensive than a shopping cart. How do you imagine people kind of managing that?
Well, yeah, again, I mean, the
This is why
wheels are
B2B is
there.
better.
Yeah, I mean the wheels emphasize the sort of lightness of the product, but I think that kind of scenario again wouldn't be on wheels. It'd just be a fixed install with machine bolts and so on. The wheels would come into play again in the Hertz case where where you're in a building, you're in a controlled environment, you're trying to like turn your cars quickly. You want to be able to move this thing around just because you have a lot of vehicles to turn. In the retail type environment, I mean, I'm assuming you're going to bolt it down. I think you have to. There's a bunch of regulations around that probably. So the wheels aren't a necessary part of the product. They're just there for certain use cases, and we can convert them to either form factor.
So now I want to talk about you being, a startup here in California in the energy transition. What are some resources that you've kind of discovered or been able to leverage in California as a startup in the energy transition? I know you applied for CalSeed.
I mean, I think there's a lot of good stuff we're trying to tap into around Sacramento in particular. I know there's a lot of industrial development kind of going in over there. It's going to be like I feel like it's going to be kind of the hardware startup-y nexus of California, whereas the Bay Area is a software startup nexus. So we're starting to see some of that, and we're obviously actively applying for various resources over there, and work networking our way through and meeting people, and it's kind of interconnected. And so yeah, we're pretty bullish on that in the sense that there's an advantage to both California and Michigan kind of here. Michigan is very concerned about losing the car industry to China. So there's a national industrial strategy around like battery production and EVs and that kind of stuff happening there, and a lot of engineering about cars in particular. California is also very friendly in another way towards both obviously startups and also the fact that it's kind of the Goldilocks area for having EVs. I mean, like Michigan's not that friendly because they have winter. I mean, like this will all get better, but right now, if you want to have an EV, California, it's effortless. It's great. I mean, it's just the weather's perfect for it. There's a lot of chargers. So I think having a foot in both locations is pretty important. So we can't just
Mhm.
be a Michigan company. And yeah, like California, we can eat the dog food. I mean, the utilities here are far ahead in terms of this kind of battery placement in behind the meter stuff too. So the critical thing about California too is that the transition is farther along for obvious reasons, and utilities are out there just farther along the curve of doing these things that we think are ultimately going to be our market everywhere.
So tell me a little bit more about, your experience in dealing with utilities, because I know compared to most of the startup world, they move a whole lot slower. But I also know, PG&E just had a competition last year with their Epic money for innovation. SMUD here has supported a lot of innovation projects and adoption of new technologies on their grid, like flow batteries, iron batteries. What's been your experience in working with utilities, and how have you managed that?
Well, we haven't done that much yet because we're still kind of finishing off the prototype. So we haven't had to engage with them quite yet, but we're starting to really want to because we want to think about requirements around this kind of co-location stuff and the technical and regulatory requirements. And so we're kind of just now anxious to start talking to utilities. And one inroad we found isn't so much like the mega utilities, but the rural electric cooperatives. There's about 700 of these things in the country, turns out, and they're running sort of small utilities all over the place, specifically out in dispersed areas. And we're working with one right now in Texas. And we think that's a very friendly entry point because they're small, they're easier to approach, but also they have particular mandates and directives. So one of them is bringing obviously power out to rural areas. Another one is bringing EV charging out to rural areas. In some cases, they're doing internet bandwidth because they're the only one in town that can do that too. And so that kind of, to the extent that we're trying to address the rural problem, that's a natural on-ramp to talking utilities in general, we think.
Mhm. That's interesting. So, at CleanStart, we actually go around the Central Valley to rural counties with our outreach trailer and talk to them about the energy transition. And they're like, well, how are we ever going to get charging out here? We're at the end of the line and we have a small rural co-op, but that sounds like a good, opportunity to go and prove it, because I think they have a lot more control and they probably pay attention to people a little bit more. I know SMUD, with its being a public utility and having elected board members, pays a lot of attention to what we think here. But so like I want to kind of talk more about your growth. You came up with an idea.
Mm.
You said, okay, well, I need to engineer it, do prototyping, a lot of the development down in Cupertino. Can you describe your kind of growth path so far that you've taken?
Yeah, I mean, this is kind of running on contacts we made from the light electric vehicle industry, especially around Michigan and so on. So we found an engineering team relatively easy in that sense. And so our focus has been a lot around iterating on the hardware product. We're kind of like a couple iterations in right now. There's a lot of sort of trade-offs to make, and we're doing different board designs and so on. So a growth path has been increasingly over time converging on get the first prototype to work. Because obviously we're also fundraising. The thing we learned, within the first few months is that everyone's a little edgy about new hardware companies, of course, for very good reasons. There's a lot of challenges there. So the message we got from general investors, but also from just grant opportunities in many cases, was just like, if you had a working prototype, like we'd love to hear more about you. Please make a working prototype. So for that reason, for the past several months, we've been focused on just getting that first one done. Getting the suitcase supercharger, as we loosely call it, to charge a car in public would be a really good milestone. So that's right now we're driving towards that goal more than anything else.
De-risking through validation. Yeah.
Yeah, de-risk the science. Don't worry about industrial design. It's literally in a suitcase. Like we bought a Pelican case on Amazon. Like
I saw that
that
picture. That actually looked pretty
yeah.
cool. I'm like, hey, that's something I could do potentially build in my garage if I had enough knowledge. Yeah, because in Sacramento we do have a pretty large prototyping, engineering, manufacturing groups here. So a lot of startups around here, they plug right into groups like the Sacramento Valley Manufacturing Association and then get to talk with engineers on it. So now, is your background in engineering?
Varied background. Physics initially, and then software engineering for a long time, especially through the dot-com boom and a bunch of startups around there, and then sort of slowly product rather than engineering, and then slowly hardware as opposed to just software. So I guess yes, in
So,
a bunch of
well,
ways.
one question that I have, because this is one that like a lot of startups end up having, is like they have this great idea and they
Mhm.
somewhat know how it works, and then they've got to go and talk to an engineer. And it sounds like you've had with product design and through the dot-com area that you've had a lot of experience in, communicating the product needs and the goals with engineering to deliver something. What's, a word of advice that you'd give to someone who has a startup that is going to go talk to an engineer or has talked to an engineer and came back extremely depressed?
Yeah,
What's
yeah.
some words of advice you might have for them?
I mean, yeah, it's been interesting. I think one sort of happy conclusion is that managing hardware engineers is fairly analogous to managing software engineers. Like you think it's going to be really different. It's kind of not, as long as you kind of basically know what they're saying. So in both cases, I mean, I'm not a super great software engineer compared to a lot of them. So if you can manage people who are better than you at engineering, it's kind of analogous. And as long as you understand the trade-offs they're kind of coming to you with, you can intelligently manage that product evolution path. So it's probably a topic for a whole other discussion. But yeah, as a product manager, moving to hardware is a lot more transferable than you think. But the other kind of interesting thing about hardware is, yes, engineers will often say things like, "Oh, it's physically impossible," and then you become sad. But often there's a moment they go, "But if you just do this, now it's 10 times cheaper and faster." You're like, "Oh." Because you can't always predict these transitions that just suddenly make everything refactor and fall into place, and it's a very kind of pleasing process. But one really big example that happens over and over again with electrical stuff and power electronics is there's heat dissipation goes with the square of current, the I squared rule. And as a software engineer, whenever you see a squared, you're like, huh, you have to make that particular factor go lower, and you're going to win non-linearly there because anytime an exponent goes down, you win a lot, right? So it's like in an algorithm, like there's an n squared, don't stop doing n. So again, in this case, lowering current, all things equal, is always a huge win. Your component cost goes down, it goes lighter and cheaper. Your heat goes down, your risk goes, like a bunch of stuff reduces just by lowering current in any one place. And part of the modularity came out of that. Like it's a nonlinear win. Like doing 5x here versus 1x, 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 1x. The second thing's a huge win because of that exponent, if you see what I mean. So as you kind of have these interactions with the engineers, you discover these points at which you're not sad anymore. Everything's kind of collapses nicely into a very elegant product as long as you accept some other constraints. So that kind of refactoring is very analogous to software refactoring, I think I found.
Yeah, we do have some engineers in the audience, and I haven't seen their hands go up, so I'm guessing that they agree with you to some
Yeah, I mean
to
it's a kind
some
of
extent
crude
on that.
a crude explanation, but yeah, no, I mean
Yeah.
like physics is physics and you can't fight it, but math is math in software. So there's analogous wins there to be had.
So I know we have some EV enthusiasts in the audience right now, part of different groups. Peter, Cynthia, Rod. Any comments or questions you initially have about, what you've kind of seen here? Wow, they're usually not this quiet. I guess you have a perfect solution then. Yeah, so I do want to spend a little bit more time on the multifamily unit part of this because you have a lot of people in California that live in multi-unit dwellings, or maybe they don't own their home, they rent, and they can't maybe do the capital improvement. And maybe that's, the home renter probably doesn't fall into it so much. But how do you envision this kind of working, or what obstacles do you see that's preventing it from working in a multi-unit dwelling scenario? Returning of the battery, if it's on wheels, making sure that it's, that you're calculating the cost right for the user, because I know one thing that I've constantly heard from a lot of people in the space is that EV charging shouldn't be more expensive for the lower income groups. And I know SMUD has been looking at solutions to how do they, address that. But my curiosity is how do you kind of view it? What are you looking at with the open road?
So And again, it might not be in wheels in that situation either, but
Mhm.
whatever, it should be relatively easy to stick into existing buildings without having to make physical modifications. I mean, one of the things about EVs is kind of interesting is they kind of are thought of here as a very premium technology. It's difficult to access and not very accessible. I just came back from China. They're low end technology. And this is what's kind of the major difference is that EVs are obviously fairly common in China, but they're very common at the low end. Every single cab is an EV because it's the cost of operation is lower. And we're not quite seeing that here yet, but we will. And so on one hand, the cars are just going to get cheaper just because they're simpler. It's mechanically less stuff. And so it will be kind of like the default low end car because they'll cost 30 or 40% less than everything else. But then in terms of the buildings, again, I mean, I expected to see a lot of charging infrastructure in China and it's just invisible. Like, where is it? And it's just in underground buildings and parking lots and multi-unit buildings. And there's not a lot of drama around it because I think their grid is probably built out relatively recently, aiming at high density. And so it's just there. So back on this side of the ocean, we've got buildings that are adequate to serve the tenants in the buildings, but not really anything beyond that. So the way to kind of make that accessible is make the charging hardware as cheap as possible. Like make it doable even without massive subsidies. I mean, it's effectively free right now, but it won't be free in 3 years. So make the hardware cheaper, smaller, lighter, and the biggest factor again is just lowering the install cost, which dwarfs the cost of the hardware. I mean, anytime you're trenching anything or adding panels or adding on-site electricity, I mean, it's game over. So I think again, just the biggest factor is just get site installation costs as close to zero as you can, and
All
everything
right.
falls out of that. And then you can subsidize power, you can do a bunch of other stuff, and you can have a software platform that has equitable power rates for certain users, and that's all just software stuff. But the biggest thing is site install cost. Just get it down.
Absolutely agree with that. It's probably the biggest obstacle now. And I think a recent quote that last year someone told me is that the cost of installation is still going up because they just picked all the easy spots to do the
Yeah,
first ones.
yeah, and that's labor cost, and labor is
Yeah.
not coming down, right? You have to do less labor, otherwise you can't make it work.
All right. And there's the question that I was looking for. Peter, go ahead.
All right, can you hear me?
We can hear
Yep.
you.
Okay, good. Yeah, I'm calling in from my phone and it's been acting weird. But my question is, and maybe it's been asked, but I don't know if it was answered. So Thomas has been talking about, how do you lower the cost for the users? But I guess my main concern is that, if you're trying to make everything equitable for people who live in multi-unit dwellings or don't have a garage or a place to charge at home, you can lower the cost of the install. You can put those chargers in multi-unit dwellings, but typically, if it's not tied to their own unit and their own meter, then they're paying an incredible surcharge, usually like 100% over the base utility rate for electricity, just for all the management fees and everything else. So do you have any thoughts on that, how you could, with your technology or your solution, lower those costs to the user?
Yeah. So apart from just lowering the install cost, which obviously gets amortized into rent at some point, so power cost, obviously, as you know, is highly variable, especially throughout the daily cycle. So just being able to bank cheap power and use it later in itself would just cut power costs hopefully about in half from what they would have been if you couldn't bank it in the middle. So the buffering and the caching is kind of important there. And then apart from that, if you want to go into new kind of clever subsidy models, whatever, because there's a software platform and a payment interface and a bunch of stuff in the middle between the the charger and the car and the user, you could just imagine buildings that just had sort of payment policies. Like if for you, if you're in a low income category, it's just cheaper, or it's cheaper because you live in the building or you live in this neighborhood versus somebody coming in from outside if it's publicly accessible or whatever. So you could do a lot because there's a software interface to sort of model cheaper pricing into the system, even if it's cross subsidized. But the main thing is probably just like power just is cheaper at certain times of the day. And the more you can grab that cheap power at night, the more you can make the power cheaper at the other end.
Could you explain that a
Oh,
little bit more? I didn't really understand how that interface worked between the unit and the charging station for the individual renter.
Okay, so and again, this is just I'm just riffing on sort of software ideas as solutions here, but because you've got a device with a credit card interface and a payment terminal and some you could imagine some user identification through a mobile app or a PIN code or something, you could just decide to charge less money to certain people selectively at the same hardware station if you wanted to. Indeed, micromobility, we did this all the time. We had different rates for low-income users built into the platform because it was, in many cities, it's a regulatory requirement. And in other cities, we just want to do it. But basically, once you have software in the middle and a lot of cloud intelligence going on, you could have user level pricing, not just time of day pricing, but also user particular pricing. And you could imagine a lot of social policy and equity being enacted that way as well.
Oh, they just use their card.
Okay. So what I am hearing though, kind of from you on this, Evan, is that so you guys don't have, you're not fully deploying these across the United States right now and are still working
Oh,
on
we're working on a
prototype.
prototype. Yeah. Yes.
Yeah. But you'd be open to trying to engage with multi-unit dwellings to figure how this would work for them, what the concerns are, and see where solutions potentially could be, right?
Yeah, absolutely. Yeah. This is the time we'd like to learn about these requirements and features that would make the product better for these particular use cases. So absolutely, yes. But I'm just saying because it's software, we can build in whatever anybody wants. But this is one way that I suspect is just going to happen, where we do have user-specific pricing, just because I've seen that in a bunch of other industries.
Yeah.
Could I ask a question?
Who is that?
This is Ari.
Oh, Ari, go ahead.
I just wanted to expand a little bit on, I have the question about the economics. So you have multiple factors that increase the cost of charging when you have these batteries. You have to pay for the batteries, there's maintenance, people going out to the field to fix them or whatever. There's the losses that you talked about a little bit before, but if it's round trip, if it's 85%, you're losing a fair bit of energy charging and discharging. And then but also very significantly is the long delay. So if you have a fast charger, you could theoretically just fill it up constantly. Somebody could plug in continuously. I don't know what the actual utilization rate, for instance, of a Tesla fast charger or some other fast charger is. But with a battery, you're limited in how frequently you can charge it. And then that introduces the timing of when it charges. Like if you're only going to do one charge cycle in the morning, say, you could charge that at night. Charging it at night though is going to be dirty energy. So you're going to increase emissions if you charge at night. So you could charge during the day. Again, you might get one hit out of that you discharge this thing. And then if somebody else shows up and they want to charge it at night so they can charge again. So you've got these scheduling issues. So all that is going to impact your economics and drive up the cost. So how does that change the cost of charging above, just the cost of the energy that you would otherwise?
Yeah. These are really good sort of second order questions here. So there's two aspects here. So the first thing is, what about the charge cycles? What about the timing? So an important aspect of this product I kind of really didn't get into is we can always pass through whatever the circuit is doing. So if there's a level 2 circuit doing input to the battery and the battery goes to like 0, we can still do level 2 charging at all times. Or we can do a mix where it's doing sort of level 2.5 all the time. So you could imagine getting 10 kilowatts out of the wall, topping it up by 20 kilowatts out of the battery, and then deploying the battery more slowly over a wider range of customers and getting 30 kilowatts, which is still pretty good. I mean, it's way better than level 2 for a longer period of time. So that kind of power mixing aspect here is important. And again, it might not be on wheels. It's probably going to be plugged in all the time. So you can always kind of have this baseline power source that would be there anyway. So you can think of it as like the world's best level 2 charger because it goes level 3 a lot or level 2.5. And sorry, what was the second part of the question?
Kind of economic. So generally on the economics. So there was some on the cleanliness of the energy going into it that you addressed partially for the mixing, but you've got a cost of running this, paying for that battery, the capital cost of the battery, and then just all the O&M that goes into and replacing the battery after a few years. So all this stuff.
Yeah.
That's additional to just having a plug in the wall.
Yeah, the battery adds capital costs. So yeah, of course, I mean, good point. So again, the sweet spot's going to be you also want the battery anyway. So to the extent that you want to put batteries all over the grid for resiliency reasons and you want to get fast charging, like it's having both at once will be advantageous. But yes, I mean, ideally you get some value out of the battery itself anyway, even when nobody's charging. Like you get to back up the building, you get to store solar energy. I mean, and again, the reason why I'm kind of bullish on this use case is that PG&E in Sunnyvale and Cupertino is paying to co-locate power walls in customers' houses with solar. And they're just capitalizing the whole thing through Sunrun because it's advantageous enough in itself without charging cars just to have that stuff in place because it alleviates some other issues about building the grid out faster. So our hypothesis is that there's enough of a win here when the Venn diagram overlaps of connected batteries and charging that there's a product space right there that no one's in right now. But yes, to the extent that you're capitalizing batteries, you want to get other value out of the batteries as well. And we hope to do that.
Thank you.
Well, I think that we covered a whole lot on this. And from everything from the charging, the future opportunities for you, and also, some advice for entrepreneurs in the region. Well, I hope to see you bring your solution to SAC and, maybe see some open road charging things here in the future.
Yeah, no, California Mobility Center, I'd love to demo in there and so on. So
Oh
yeah.
yeah, absolutely. Any last words before we close it out?
Oh, there's a question now.
Where's PG&E building power walls and apartments?
In my house, apparently, in about a month. So what I was told by Sunrun, who's kind of doing the operational side of this, is they're going after parts of the grid where, ironically, there's a lot of EV penetration because it's putting a lot of local load on stuff. So in this part of Cupertino, we used to never have blackouts, but when they started slicing the grid smaller to sort of detune it around various fire hazards, we started having a lot of blackouts last year. And the problem is apparently just a lot of EVs on this street. It's like 1/3 Tesla when you kind of look down the street. Like Apple's just over there. They all charge at work. They come home. So the answer seems to be that they're going after places where the load is hyper locally very high and trying to get individual houses essentially 100% just off grid. So currently it seems to be at least Cupertino and Sunnyvale. I'm sure a bunch of other places as well, but that's where I know it's happening because they're doing it here.
All right. So then, any last words
For me?
for you?
Yeah, no, I mean, like I said, I feel like, I mean, and that particular detail is kind of interesting because we had this prediction in our investor deck that utilities might want to put batteries in places. And then one day Sunrun just comes to the house and offers to put batteries in the house. I'm like, really? Please come in. I'd love to hear more about this. So that felt very vindicating in the sense that this stuff is happening now. It's closer than I thought it was going to be. It's just like dispersed batteries at the edge is an actual real thing that's being built out right now on my street. And so, yeah, I think I don't want to say I told you so because I think everybody saw it coming, but it's coming faster than we thought. And it's kind of cool to sort of see that shaping up like that.
And it sounds like some good competition for SMUD as best utility. All right. With that, I want to thank Evan for joining us today. I also want to thank our supporters, SMUD, Bloom, Fresno State, River City Bank, and ChicoStart. Along with those of you that have contributed and donated to CleanStart, you validate what we do here. And I want to encourage the rest of you to join our next webinar, which is on Vehicle to Grid with Casey Mars and Vanessa Fior. It's on September 5th. They have a lot of experience doing vehicle to grid projects across the country, here in California and in Canada. And then we have a future discussion on a circular economy on September 26th. That's an in-person event here. And earlier that day, we're going to be talking with Wind Harvest Energy about their vertical axis turbines that they are building here and have fundraised for. And thank you for attending. You can follow us on Instagram, Facebook, LinkedIn, Empower Innovation Network. This is live on YouTube, and check us out on our website. Thank you very, very much, and have a good day.
Yeah. Thanks, Thomas.
Thank you.